All right, hopefully we'll finish this up. It's taken us a long time to get through this lesson. But again, I told you last week, this is one of those big major lessons that you do. Okay, some of the lessons, it's just a little bit more than what we did before, but this one's like a major thing. So let's go through it real quick. Did we do, I'm trying to remember all the stuff that we did. Yeah, we did standard form, didn't we? The ax plus by equals c. Yeah? Okay. I was just trying to remember where we left off. So let's do a little review. We've had a weekend, so let's just take a look. Let's do slope intercept first. Okay, so slope intercept form. All right, so if you weren't paying attention last week or you just forget, we're going to do it now. All right, so yeah, what is it, Alani? Good. Y equals mx plus b. All right, that's slope-intercept form. All right, so what do we know about y equals mx plus b? Well, we know that. What's that thing? What's the m stand for? It's just the slope. Okay, so that's the slope. And what is that b? It's an intercept, but which intercept is it? It's the y-intercept. Okay. All right, so that's the y-intercept. So anytime you see something like this, so if I ask you to graph something, let's go 3/5 x minus 4. Okay? Again, this is review. We've already done this, but we want to do it again. Repetition is the key to learning. You ever hear that phrase before? Now you have. What's the phrase?
Repetition is the key to learning.
That's correct. Repetition is the key to learning. So when you do things over and over again, it's going to help you learn. Which brings to mind, I don't want to get on you too bad on a Monday morning first thing, but it brings to mind the learning the distance formula, the thing you just took the quiz on, the distance formula, midpoint formula, and slope. Somebody tell me what I told you guys when we first did the distance formula. I said, you're going to have to memorize this, right? And you did, didn't you? Wasn't it on the quiz where you had to write it down? Yeah. So you had to memorize it. I said, what is the best way for you to memorize it? What did I suggest to you? Which I doubt a whole lot of people did. Write it down every single time I give you a problem, okay? So every time there was a problem on distance formula, you should have written down the distance formula. If you did that, okay, if you write the distance formula down on your homework, every single problem, I'm telling you, you're going to remember the distance formula. The reason that probably half of you did not get the distance formula right on the quiz is because I would say most of you did not write it down every single time you had it on a homework. All right, I'm not going to have you raise hands and ask who did or who didn't. I kind of know. All right, I know if you didn't do it. So that's what I mean by repetition is the key to learning. If you write it down every single time you have a homework problem, you're going to remember it because you're repeating it. You're seeing it over and over and over again. All right? So that's what I'm talking about. Same thing with this stuff. Y equals mx plus b. Write it down every single time you got to do something. All right? So if you had this and I asked you to graph, and this will be, maybe not these exact numbers, but this style of problem, I'll say graph this, all right? Or graph the line. It might say graph the line y equals 3/5 x minus 4. And you got to show me how to graph it, all right? It's not too hard. You don't, on this particular problem right here, you don't have to do any math. No algebra, no nothing, all right? All you got to do is know a couple things, all right? We already circled a couple of these. I'm going to do it again. Repetition, right, is the key to what? Anybody here? Okay, very good. Repetition is the key to learning. You've never heard that phrase before. It's a very popular phrase. People say that all the time, but that's all right. You guys are just in 10th grade, so maybe you haven't heard it, but now you have. So what is this thing right here? The what? What? Which is the what? Give me one word. Give me one word. It's the slope. All right? We just wrote it down up here, didn't we? See? Right there. Slope. All right, very good. Is it 4? Is that a 4? It's a negative 4. You got a minus in front of it. That's a negative 4. What is that? That's the y-intercept. I'll just put int for intercept. Now, how do we graph it? You're basically, all you're doing is just putting down 2 points. You're just looking at the numbers. You got to put the points in the right spot, okay, obviously. So you put the points down, you connect the points, boom, you're done. It's really, really simple. So everybody should have your head up. Watch what I do. What's the first thing that I'm going to graph here? The slope or the y-intercept? The y-intercept. This is the first thing. This is first, okay? That's the first thing I put. What does it mean to be the y-intercept? It crosses what? The y-axis. Okay, it's the y-intercept. It's where it intersects, all right, the y-axis. So I'm going to put my point on the y-axis. This is the y-axis. Where am I going to put that point on the y-axis? At where? At where? At negative 4, right. So 1, 2, 3, 4. And I put a dot right there. Okay? Abdul, you watching? You seem preoccupied. What's going on? Well, look up here. That's what you should be looking. All right, so that's our first step. Everybody got that? You look at the y-intercept, and you put a point on the y-axis, the one that goes up and down, the vertical one, at negative 4. 1, 2, 3, 4. Now, what's the second thing that you're going to do? You're going to do the slope, which is rise over run. Where do you start? At the y-intercept, right, at this point. And what am I going to do? I'm going to rise, and I'm going to run. How far am I going to rise? 3. So I got to start at the y-intercept, and I go what? Up or down? Up, because it's positive 3. So I go up 3. 1, 2, 3. Do I put a point yet? Nope, not yet. I still got to do what? Got to run. How far am I going to run? 5. That means I go which direction? To the right. 1, 2, 3, 4, 5. And then I put a point right there. Do I just put those 2 points there and I'm good to go? What do I got to do? Draw a line between them. Do I just connect from here to here? No. I keep on going out like this. I keep going out like this. And then I'm good to go. And there it is. I wouldn't mark off for this, but you really should put little arrows because the line keeps on going. It doesn't just go from one point to the other and stop. It's not a line segment. It's a what? Graph the what? The line. That's right. This is a line. All right. So a line has arrows on the ends. And that's it. That's your answer. If that was a quiz or a test, hopefully that projector stays on. I don't know what's going on with it, but all right. Everybody good with that? All right. Now, that was the easiest one. That was the very easiest one that I would ever give you. All right. Doesn't get really any easier than that. So now we're going to do, we just talked about the what form? The slope-intercept form, correct? What was another form that we did? Standard form. All right, this projector is driving me nuts. Okay, we're back on again. All right, so it's the standard form. Let's write that down. Standard form. All this is review. Okay, we've done this before. All right, go back and watch the videos, but I'm going to review it again. So ax plus by equals c. All right. Now this one does take a little bit of work. It takes a little bit of math, takes a little bit of algebra to be able to graph this. So if I ask you to graph something that's in this form right here, you're going to have to do a little bit of work. But before we do the work, let's talk about it just a second. This A, B, and C, right? The A, the B, and the C. You might see this in your notes. Probably looks just like this. The A, the B, and the C have to be what kind of numbers? Positive or negative? Integers, that's the word. Okay, if you look in your notes, you'll see this word, integers. Integers can be positive or negative or 0, because 0 is not either positive or negative. But they got to be integers, which means they can't be what? Fractions. They can't be fractions or decimals. All right? So A, B, and C have to be integers. Now, A is a little bit more specific. A has to be positive. It's got to be a positive integer. I'll just put int. All right? So A's got to be positive. All right. We're not really even going to get into that too much, but that's important to understand. All right, so here's an example. We did this example already, and let's do it again. This is example 2 in the book. Oh my goodness, this projector. I'm getting a bad connection, and I don't know what to do. Come on. If you're watching this on YouTube, my projector is going in and out. And now it's out. It's got no signal. I think I've got a bad connection somewhere. Let me try it. So I'm trying to mess with it. Oh, goodness. Let me put the mic down. What's that? I'm trying to put it in the position where it'll stay and it's not going to move. So I stuck it here. Take it out, put it back in again. When you hear that buzzing right there, usually it's making a connection. When it stops buzzing, there we go. Now it's working. We'll see how long that works. I don't know. All right, let's try this again. That's what happens when I use all this technology. If I just had a good old whiteboard or a chalkboard, wouldn't have to put up with this, would I? But then I couldn't record my lessons. Well, I guess I could. I could just put a video camera out. There's a lot of... Have you ever seen any YouTube videos? You probably don't watch too many math YouTube videos. But there's a lot where people just put a camera up and then they just shine it to a board and the teacher's up there teaching. But that's not what I'm doing. All right. Actually, let's just do this. Let's just say graph this. All right. I think this is probably the same exact numbers that we did earlier. So if you took the notes before, you probably got it on there. But let's do it again. All right. Like I said, repetition is the key to learning. So let's do it one more time. So I got to graph this. Well, what form is this in right now? It's in standard form, okay? There's a couple ways we could graph it. All right, I'm going to show you both ways. Didn't we do x and y intercepts before? Yeah, so let's do it that way. All right, and there's another way too. We could take this and change it into slope-intercept form. But I'm going to do both ways. All right, so here's, I'll just put a 1, and we're going to use, oops, that's an ugly U. We're going to use x and y intercepts. Okay, so this is 2 ways to do it. You don't have to do it both ways, but there's 2 different ways that you could graph this, or at least 2 ways that we're going to do. All right, so let's use x and y intercepts. Some people like this better than the other way I'm going to show you. All right, so let's watch. Let's find the x-intercept first. So I'm going to put x-intercept right here. And how do we find the x-intercept? If you want to look in your notes, look in your notes. You probably wrote it down because I wrote it down when I taught this. How do you find the x-intercept? You set something, y equal what? 0. That's right. So if you're going to find the x-intercept, you set the other one, right? The y is the other one, right? You got x and y. You set the other one equal to 0. So let's do that and find our x-intercept. This is what I'm using right here. This is my formula. Or it's not my formula, really. It's my equation. It's the equation of a line. So what am I going to do? I'm going to set the y equal to 0. So what am I going to have? I'm going to have 3x plus what? 4 times 0 equals negative 4. And I'm going to solve for x, and that's the x-intercept. That's where it crosses the x-axis. All right? So what happens here? What's 4 times 0? 0. So it just goes away. So 3x equals negative 4. How do I get x by itself? Subtract? Do I? I add? That's even worse. You divide. Why do you divide? Why do you divide? Because what's that 3 doing to the x? It's multiplying. Okay, I'm not here to teach algebra. You should know that already. So anyway, so I divide both sides by 3. X equals negative 4 You know what? This is a terrible equation to use for using the x and y intercepts. You know what? Let's try this again, because we're going to have to put negative 4/3. I tell you what, I'll show you why it's terrible. Because look, what is negative 4/3? Well, it's the same as negative 1 and 1/3. Do you really want to graph that? Okay, look, here's negative 1, here's negative 2. Negative 1 and 1/3 would be right there, wouldn't it? I mean, you could graph it, but you're kind of guessing, aren't you, where a third is? Everybody see that? So that's probably not the best equation. You could do it this way. I tell you what, let's just continue doing it this way, all right? It's perfectly fine. Let's put a graph here. I should have looked a little bit closer to what I was doing. All right. So let's do the y-intercept now, and then we'll graph it, and we'll come pretty close. Let's do the y-intercept. So if we want to find the y-intercept where it crosses the y-axis, what do? We set what? We set y equal to 0 again? No, look. To find the x-intercept, we set y equal to 0. To find the y-intercept, what do you think? We set x, right, the other one. We set that equal to 0. So let's do that. 3 times 0. Right? So I make that x is 0 plus what? 4y equals negative 4. That's a 0. Divide both sides by 4. So y is negative 1. So let's do this. It really wasn't that hard. Okay? Making those 0, it just got rid of the y. Making this a 0 just got rid of the x, and we just divide by one thing. So the math was pretty easy. Just divide by a 3 here, divide by a 4 here, and then we're ready to go. Let's graph it. Remember what I said about the x-intercept? This is probably not the best problem to use x and y-intercepts, but let's do it anyway. Negative 1 1/3. Well, there's negative, remember, this is the x-intercept, so it's crossing the x-axis. Okay, this one is the x-intercept, this one is the y-intercept. So this is going to be negative 1 1/3. Negative 1 1/3, again, I have to guess where a third is, okay? I can't be super accurate with that, but that's okay. That's a pretty good guess right there. There's negative 1 1/3. What's the y-intercept? It's negative 1. So what am I going to do? I'm going to look at the y-axis. I'm going to go to negative 1 on the y-axis. And then, what do I do to those 2 points? Line them up, and there we go. Let's take it all the way. All right, that's pretty close. And put arrows on it, make it look nice. There we go. So that's one way to graph that equation. It's not too hard. Just look, just cancel this one out and solve for y. Cancel this one out and solve for x. Right? You got your x-intercept, you got your y-intercept. Let's do it a second way. So that way was using x and y-intercepts. Tell you what, I'm just going to get rid of this just so that I can keep on my work right next to the graph. Let's do it another way. 3x plus 4y equals negative 4. This is the way we did it earlier when I first taught the lesson. So if you go back and watch that lesson, this is what we did. What we're going to do is we are going to use slope-intercept form to graph this. Slope-intercept form to graph it. Well, what's slope-intercept form? It's y equals mx plus b. So this means we want to take this thing and get y by itself. We want to solve for y. All right, so let's come over here and let's solve for y. I did it earlier, or last week, so you can go back and look at the video. I probably explain it maybe a little bit more detail, but I am going to get rid of the 3x, so I subtract a 3x from both sides. That cancels. I'm left with a 4y. Now, this is mx plus b. I like the x to go first. I don't want it to be minus or negative 4 minus 3x. So I just switch the order. I put negative 3x minus 4. It's the exact same thing as negative 4 minus 3x. Okay, I just switch the order. And then what do? Divide by 4, divide this by 4, divide this by 4. See what we get. These cancel. Y equals, look, I got negative 3 over 4. That's my fraction. That's my slope, negative 3/4. Then I just stick that x right next to it. And then what's this? Minus 4 over 4. What's 4 over 4? It's negative 1, minus 1. Now what I'm going to do is now I'm going to graph this. It should be the same exact graph as this one. All right, it should be. Let's see if it is. So, first of all, what do we look at? The y-intercept is negative 1. Well, look, the y-intercept on the other one was negative 1 as well, wasn't it? And it should be, because remember, these are going to be the same graph, just two different ways to graph it. What does this say, though? That's our slope, negative 3 over 4. So I could start here, and I could do what? Go down or up? It's negative 3. Right, it's negative 3. So I'm going to go down 3. 1, 2, 3. You're like, yo, Mr. Hammer, this is not going to work because, look, I'm way down here. Look at that red graph. It's way up there. But what do I still have to do, though? I got to run, what? 4. So I go to the right 4 places. 1, 2, 3, 4. See how the red one was just a little bit off? Because remember, I was guessing where negative 1/3 is. Agreed? So let me get a closer look. See, this red line should actually go through that. It's supposed to be a point. Kind of looks like a, I don't know what it looks like, but anyway, it's supposed to be a little circle. So really, it should go through right there. So if I was going to be really accurate, I would have my line go like this. Let's zoom out a little bit again. So it doesn't quite look exactly like the red one. Would you agree? It looks just a little bit off. Why is the yellow one just a little bit off from the red one when they should be exactly the same? What's the problem? Did I do something wrong? What do I keep saying about that negative 1/3? You got to estimate where it is. That's right. So my estimation probably wasn't very good. Everybody understand that? All right. So the yellow one is actually probably more accurate because there's the negative 1 is the y-intercept, and then I went down 3 and I went to the right 4 right on that point. So that red one, I should have tilted up a little bit if I would have been a little bit more accurate, okay? So they should be the same graph, but they look a little different just because of that negative 1/3. Oops, let's do this. All right. All right, have I confused everybody? Yeah? Yeah, looks like it. I can tell by the looks on your face. All right, let's continue to a little bit more. Here's a real easy one. I don't give you an equation. I don't think we did this last time. So this is relatively new, but it's the same kind of stuff that we just finished doing. This is example 3. Did we do example 3 the other day? I didn't think we did. This says, write an equation of a line. I'm going to write that down. Everybody should be writing this down too. Write an equation. I say everybody should be writing this down. I still, out of the corner of my eye, see people that don't have anything on their desk, aren't writing anything down. Most of you are, but I see quite a few that aren't. I don't know what else I can do for you. All right, don't ever ask me for extra credit or anything else if you're just not going to even take notes. Don't even think about it. All right, so here we go. This is a question you could see on a homework, on a quiz, on a test. It says, write an equation of a line. And we're going to put this in slope-intercept form. Okay, we're not going to do the standard form right now. So on the quiz, it will probably tell you what form to put it in. Okay, this is slope-intercept form. Write an equation of a line that goes through this point and has, you know what, I forgot something here. And has a slope. This is a slope. All right, so has a slope of negative 1/2. Everybody write that down? Write the whole thing down. Write an equation of a line that on a quiz or at homework, I think it says that passes through, I just was lazy and I didn't write that down in my notes, that passes through the point negative 5, 6 and has a slope of negative 1/2. So how in the world am I going to do that? Well, what is slope-intercept form? Just the general form. What is it? Good. Everybody should remember that, right? If I just, I don't think I do ask you on a quiz or a test or anything, but if I did, and if I just said, what is the slope-intercept form, that's what you should write down. Everybody should have that memorized right there. Okay, so what are we going to do? Well, there's a couple ways you could do it. I'm going to show you just one way because I have a feeling showing you guys two ways to do things just makes it more confusing. So I'm going to show you just one way to do it. Everybody with me? So here's what we're going to do. On this little formula right here, on this little equation of a line, what do they tell me already? They give me a point, negative 5, 6, but they also tell me what? The slope. They tell me m. So what are you going to do with that m? You're going to put it in for where the m is. Exactly right. Everybody see that? So we're going to put negative 1/2, right? Put a y here. I'll tell you what, I'll do that. Y here, x here, plus b. So they told me negative 1/2, so I put it in for the m. What do you think this is right here? This negative 5, 6. It's just a point that lies on the line. So if I drew my line, negative 5, 6 would be on that line. So that means that this is an x and this is a what? Is a y. So guess what I'm going to do with that negative 5 and this equation right here? Put it in for what? Put it in for x. Good. What do you think I'm going to do with that y? I'm going to put it in for that y. Everybody see that? That's a key to this problem right there. Make sure you see that. I put an x and a y on top. You should put an x and a y on top so you know what you're putting into this. So now I already put the m in for this equation. Now I can put an x in here, and now I can put a y in here. Everybody with me? All right, so let's do it. So what's going to be in place of the y? 6. Good. Equals negative 1/2 times what? Times 5. Or not just 5, though, but what is it? It's a negative 5. Good. And I'm going to put it over 1. Why would I put it over 1? Because I'm multiplying by a fraction. That's right. So that's why I'm going to put that over 1. Then plus what? B, which is the y-intercept. So let's solve for B. Let's solve for the y-intercept. Because they already gave me the slope, right? And if I find the y-intercept, I should be able to graph it, right? If I find the y-intercept and then I find the slope, I should be able to graph it. But they don't even ask you to graph this one, all right, which is nice. They just want the equation of a line. So let's do this. Well, I can't do anything with that 6. I can do stuff with this fractions. I got a negative times a negative. What's that going to give me? Positive. And then how do you multiply fractions? Just multiply straight across the top, straight across the bottom. That's all you do. Very, very simple. All right, so let's multiply across the top. What do we get? 5 over the bottom, 2. All right, everybody with me? There's no x because I put a negative 5 in for the x. What do I put now? Plus what? Plus b. Now what I want to do is I want to solve for b. Now, this is probably the hardest part of the whole entire problem. All right, I got to get rid. Oh, you're touching the thing. Okay. So I want to get b by itself. So I have to get rid of the 5 halves. How do I get rid of a positive 5 halves? Oops. No. This is being added. This is being added. How do I get rid of something that's being added? I subtract. Okay? So I subtract. And then I got to come over here and I got to subtract it from this. Here's where the problem is. Right? You know that cancels out. So I've got b equals, how in the world do I subtract these? Well, that's 6 over 1, isn't it? I need to find a common denominator when I add and subtract. So what's my common denominator? I got a 1 and a 2. What would be my common denominator? It'd be 2. So if I multiply this by 2, I got to multiply that by 2. So what does that give me? 12 over 2. Good. So it's 12 over 2, what? Minus 5 over 2. Now we can now we can subtract those from each other because I get a common denominator. So all I do is go 12 minus 5. What's 12 minus 5? 7 over what? 2. And that's my y-intercept. So check this out. I know a slope. What did they tell me the slope was? They told me right off the bat. Negative what? They told it to me, okay? So the slope was negative 1/2. I just found the y-intercept. What's the y-intercept? 7 over 2. It's not my answer. I need to write it in slope-intercept form. So how do I write? Here's my slope-intercept form again. How do I write my equation? Well, I gotta put some other stuff. I gotta put y equals, and then the m. What's the m? The m. Look at it. Negative 1/2. It's not negative 1.5. It's just negative 1/2. And then I just write down that x, and now I write the b. I just did all that work to find the b. What is the b? Plus 7 over 2. That right there is my answer. That's the equation of a line that goes through the point negative 5, 6 and has a slope of negative 1/2. I know we're going to have to do those again but it's there. It's recorded. You can go back and look. All right. Hopefully you wrote all this stuff down. But believe me, I know that you're going to have a little more practice on this. And I am. I'm going to give you more practice with this stuff. I know that's what you want, right? All right. I still have a little bit more to do. I thought I was going to finish it today, but I'm glad I went over the review a little bit. And, yep, I think we're good. Let's do one more. I got a few minutes left. Let's use the time we have left. Just kind of reviewing again. I know that thing's going in and out, the projector, but it seems like it comes on again, so we'll just do this. I'm going to do an example that we've done already. Example 1. And here's what we're going to do. I'm going to go through it a little quicker this time. They didn't ask you to graph it, no. Sometimes they just ask you to write down an equation of a line. Sometimes they... Oh, come on. This is driving me nuts. Okay. Could barely hear. Oh, goodness. I thought putting it this way would help, but apparently it's not. Let me try something else. Oh, goodness. It worked better this way, so let me try it this way. Well, maybe we won't be. Come on. I can't go through class without this working. Might have to hook up another cord